Hello everyone, I hope you're well. So today I'm going to share with you a life cycle assessment using OpenLCA software about a product where we can define scenarios and look at the same product with different scenarios. So this for this learning, we are doing a very simplified version of an exercise in which we are going to use a cutoff method and we are not going to look at some part of this LCA. Okay, so let's get started. First thing first, in an LCA, we want to look at what is the system boundaries, right? What are the things that go in and what are the outputs? So in these simple scenarios that we define, we have 4 scenarios. We have 2 types of bags. One is the high density and one is the low density, which is LDP. For the high density, we only use it once, so there are only, and then we say our functional unit is the number of bags that a person used per year. So our functional unit is quite unique here. It's a usage of that bag per year. So that 408 bags for scenario 1 is our functional unit, and for scenario 2 and 3 is different number of bags, but also it's a usage throughout the year. So if, for example, if you use it 10 times, the same number, 408, could be, we could use for 41 bags instead. And then if you use it 5 times, so we can use for 82. And then if for the low density, we only use it once, so it's the same as a high density, so it's 408 per year. So our functional unit, just have to remember, it's a year annual usage of that bag. So we in this little exercise, we only are taking care of the 3 raw material that is in the input. So let's say the input material is the high density granulate, the cardboard, and low density granulate. So these are the input. And then how many stages? So we have the raw material, then we transport it to manufacturing. And then instead of having a process for the end of life, we are just going to, after manufacturing, send it off to the treatment. So we basically have in this exercise 3 processes. So our first process is raw material. For raw material, our input going to be the raw material itself. So this 3. And then, so we have the sum of this all these 3 going into the transportation. So that's one flow. And the other flow is the transportation gram, tons, or kg per km, which is going to be our distance and the weight for the truck or the lorry, how we're gonna transport. And then again, on this flow is the same as here. All the weight of all this raw material is going to manufacturing plus electricity to manufacture those materials. So we have 2 flows here, 2 flows here. And then for the output, we have 4 ways of treatment. One is landfill, the other one is incineration, recycling and reuse. But since we are using a cutoff approach, we are not going to take care of recycle and reuse. Okay, so we are just going to end it with these 2. So first thing we need to know, going to our OpenLCA, is we want to input the processes. Okay, so let's see what we have. So here I'm using the ELCD method under this ELCD. So we have how many? We have the project, we have product system, processes, and flows. First thing we want to take care of is we can come up one by one from flows. So if we look at our system boundaries here, all the raw material, we can find it in the library and as well as end of life, but the in-between flows, that doesn't exist. I mean, the electricity exists and the transport exists, but these 2 is we have to make. And this is something we are going to take from here and then continue it. In this way, our processes are going to be connected with each other automatically. So at the beginning, I'm going to make 1 flow for here and 1 flow from here, which doesn't exist in the flow systems of OpenLCA. So to make things easier, I have this done, so it will get shorter time. So you better, in your flow, you create a new child category. And then I'm going to call it HW2. And under the child category, I'm gonna make the 3 flows that is not. is not in it. So, and here this goes to the recycling treatment, but the main output is the bag itself, right? So we have three outputs. We have the transported material, we have the raw material, and then we have the bag. So the raw material is the first one. I'm going to call it first. First flow, because it's the raw material here. And then the transport material is the second one, and the bag is the third. Okay, so once we have our flow, we're gonna create our processes. So the same way, in under the processes, we're gonna create a child category. So I'm gonna call it also SW2. Under the child category, so we have how many processes? We have three: raw material, transportation, and manufacturing. I'm gonna create a new process. So we have it here, raw material, have to select what is. So when you want to create, you have to select the flow. But this flow that you're creating is the output, the main output. So looking at here, what is the output of here is number one, right? Is the sum of all the raw material. So I'm gonna create say that this is my output. Okay. And then I'm going to make another one. So let's or we could do one by one. We could put the inputs here. So for the inputs, what did we have? We said we have high density, high density. So we select that. And then we say we have low density, right? And then for the cardboard, instead of cardboard, we don't have it, so we put graphic paper. It's similar. So these were our three inputs. Okay. The next thing is when we want to define a scenario, we need to use parameters. Why? Because we don't want to run the simulation 4 times. We want to do it once for all the scenarios. So you can do that by inputting parameters. Instead of writing the amount, we're going to write in here the parameter. Okay, so in parameters, we have two kinds of parameters. We have global parameters and we have local parameters. Local parameter is input parameter. What are the global and what are the local? So things like electricity and transportation, which depends on the location that you're setting in, will be local. So I will add them here. But here in this process, I don't have a local parameter, right? Because I don't have transportation. We will see next. But here, because it's the raw material, that will go under our global parameters. Okay, so how do we create a global parameter? Here I have it. Global parameters are under indicators here. So if you see this red one, this is global parameter. So to create that, you can again create a child category like I made here, and then you can add new parameters. For that, you actually the amounts out here, you can put like, for example, the HTPE, but the amount doesn't matter because we're gonna see later, we can input the amount later on when we are creating the project and calculating that. So we are not gonna put them on. So I have my global parameters here. I'm going to add it in my raw material. Okay, so it's already there once you do it. So you just have to remember the name. For example, I'm just going to take their copy their name because I don't want to type it. I just press rename. I just copy. So going back to my raw material here, so I'm going to input again. Instead of amount, what am I going to do? I'm going to paste the parameter. So it's every time it's going to take, I think that was my LDPE. One, okay, instead I will write. You can also just write, and then we do after. And then for graphic paper, I have cardboard. Okay. Okay, so right now you see them as the name, but what if you want to check the numbers is there? But also the number doesn't matter if you want to change it. But then you can just press this here, either the function or the number, so you can check the number. Okay. Okay. So looking back, you just have to have your system. Looking back, raw material, 3 input, 1 output, done, right? Let's look back. You have 3 input, 1 output, done. Okay, so what is important here is we want to take this flow and continue it so that the system knows that it's connected to our next step. So next step here, remember, we create flows, then we created our processes. So on the process, I'm going to create a new process. I'm going to call it transport, right? Okay. And then you have to select, remember? So when you're doing that, you have to select the flow output. So my flow output is the transported materials, right? Is the same material. I'm going to transport into. So let me show you what the transported flow is. So for my flow, the transported material. So under transport, we do the same thing. We bring in our input, our output. Our output we already selected. We have the transported material. But for our input, we had 3 things, right? First thing was flow. Bring in the flow. We want to bring in the previous flow, right? So what was our previous flow? Was number 1. So we're going to bring it in. So now it's connected to our previous flow. And then let's look at our system boundaries. So this is the flow that we are bringing, is the output from raw material. And then the next thing is the transportation. So transportation exists. So here we create a new one. We say transport. So under transport system, we have transport tons times km. So we select that. But ours is small, is gram, right? So we're going to change that. So there is no gram per kilometer. We need to convert it. So we select kilometer to km. And then for the amount, so here, what was the amount that we had? That was the total of our 3 raw materials, right? So because we want to use the parameters, you have to keep it constant. So I'm going to write the LDP granulate, scenario 1, plus this TP scenario 1, okay. So now I have, and then you can press number, you can see 6.4, and then we can see here that's the sum of these 3, so it's correct, right? Okay. So now that we have our amount, we need the amount for the transport. So for transport, the data that we have right now, we know the distance, the kilometer is 1,500, or I didn't put it here, but so the distance is 1,500, and so we need to convert this amount by, so I'm going to copy that. This, like that is gram, right? So I'm going to divide it by 1,000, and then I'm going to times it by my by distance. So I had 1,500 kilometers. Okay, so we have the formula. So everything in the amount when you're doing parameters, it should be based on the parameter itself. So for it to understand and work. So because we want to define scenarios, make a comparison. Okay. Okay, so now for our second process, transportation, done. Simple. Okay. After we did our second transportation, we are going to do the last one, So under my child category, I'm going to create a new process, which is the last one. I'm going to call it manufacturing. So okay, menu. And I remember the flow that comes in. So under my flows, that goes out, sorry, is the output. So my final output is the bag itself. So I'm going to select that, bring it in as an output. Again, going to the input and output session. So I have my output, I'm going to create my input. So for the input, let's look at our system. Two things comes in, electricity and the same sum from before. Okay, so I'm going to bring the sum first. So for the sum, it's a transported material, right? It's from the previous output. So previous output comes as an input here. And then I have electricity. So since electricity is a kind of parameter that I want to change for each of them, I go on the parameter. So electricity is local, right? It's not global because it depends on the location. So I'm going to create it under input. So I'm going to call it elect, okay? You don't have to give it a value. We're going to look at it at the scenario definition, okay? So I go back here. I'm going to select electricity. And electricity is under energy carrier and technologies. You can select different kind of electricity. It could be a mix. It could be electricity. So I'm just going to go with simple electricity. And in the amount, so now in the amount, I am going to input my parameter, which I called elect. So it's going to come up here. And for its units, I have kilowatt hour. And then remember for my material, it should be gram. Okay, so something to remember. So here, it depends on how you define your units, but in my units, it defined as a gram. So let's keep it as a gram. It should be gram. Just be careful about your units, sign gram. Put all the parameters together as a sum because it's a parameter and we're going to change it later. So it's important to check that you have all as a formula. Okay, so now the last step is for the waste treatment. I have four scenarios for the waste treatment, but since in this project, it defined this exercise, we define it as a cutoff approach, we're gonna cut it off at recycling and reuse, so we're not gonna define that. So let's define landfill. So landfill is under end of life, landfilling. So since I'm working with plastic, I'm going to select plastic. And then I also had incineration. End of life. Incineration of plastic P. Okay. Again, so landfill and waste treatment is also a parameter because you're gonna change it. So let's define here as well. I'm gonna make as we mentioned parameters, we don't need to put a value. We just want to define a function. Okay, so for my landfill, I'm going to say, okay, one thing about these two are inputs, right? But these two are outputs. So how do we define that? We can just times that by -1. So this is my land. So when we times it by -1, this means that is reverse. We are reversing it. Okay, so there we go. And this is in gram as well. Save that. Remember to save. Okay, so now we created all our three processes. We have our flows in, our input and output. Next, we're gonna make a project system, a product system. So I created the product system here as YouTube. And then I'm going to create a project. Okay, so let's make a new project. So let's call it YouTube as well. Okay, so here under the project, I'm going to define assessment. You can choose any method that you want. I created this method. So compare product system. What is our product system? We created here, called it YouTube, right? So let's bring in YouTube. Okay, here is where we define our parameters. So what were our parameters? We have all the materials, which is our global. Then we have our local here. Okay. Have our transport. No. Okay. So let's define our scenarios. We're gonna bring in 4 of the product system. We want to compare 4 scenarios, right? Same thing, we have 4 times. We're gonna call it. So let's call it scenario 1. Scenario 4. Okay, so here now we have our 4 scenarios. We can define for each of them how much values we want. Okay, so then we can do that by comparing our table here. Okay, let's, I'm gonna input something because it's not going to be the same. For example, I'm gonna put 20 here, 40 here. Okay, you can define a scenario differently. So for incineration, also they are different weights. This could be. You have to prepare your table before, so you can have all the values. Okay, so now we define our scenario and then we define all the parameters which are different. To see a report, we can say create report. So make changes, whatever you want. And then calculate to create that report. Okay, so now we have a report here. We can make a comparison between our data. So these are the different impact assessment that I created under my method. And these are the results. So there you go. You have your impact assessment method. And I hope that you learned something here today. If you have any question, drop in the comment bar. Thank you for watching and good luck with your studies.